Good evening, Chandra. Chandra, can you hear me? Chandra, Suresh, good morning.
Good morning.
Busy, huh?
యాక్చువల్లీ ఇప్పుడే నేను పోయాను.
అనుకున్నాను అదే అందుకే పింగ్ చేసా బట్ మరి ఇంక చంద్రతో జస్ట్ క్యాజువల్గా మాట్లాడుతున్నాను జాయిన్ అవుతారు చూద్దాం వెయిట్ చేస్తున్నాను అదే
ఓకే ఓకే
యా యా యాక్చువల్గా
లేడీ
యాక్చువల్గా క్యాజువల్గా జస్ట్ డిస్కస్ చేస్తున్నాం లేండి ఆటోమేషన్ ఇంపార్టెంట్ అని చెప్తున్నా
ఓకే ఓకే గాట్ ఇట్ యా
ఆటోమేషన్ మీద నడుస్తుంది మార్కెట్ మొత్తం ద హోల్ మార్కెట్ ఈజ్ రన్నింగ్ బిహైండ్ ఆటోమేషన్
యా
ఆటో కోడ్ జనరేషన్ అన్నమాట
అవును ఎగ్జాక్ట్లీ యా
ఎందుకంటే అది చేసే వాళ్ళకే వాల్యూ ఉంది ఇప్పుడు
అవును అవును
ఇంతకుముందు గూగుల్ ఎట్లా ఉండేదో
ఇప్పుడు ఇది అవును
ఈ
yes.
టూల్స్ ఇప్పుడు మనకి కొన్ని రెడీమేడ్ టూల్స్ వచ్చినాయి
ఆ,
ఈ టూల్స్ తెలిసిన వాళ్ళనే ఎక్కువ ప్రిఫర్ చేస్తున్నారు ఎందుకంటే కోడ్ జనరేట్ చేసేటప్పుడు వాట్
mm,
ఈస్ ద రైట్ ప్రాంప్ట్ అడిగే వాళ్ళకే ఎక్కువ వాల్యూ ఉంది ఇప్పుడు
agree యా
ఆ,
యా
అది చెప్తున్నాను చంద్ర
ఓకే
అడుగుతుంటే జస్ట్
ఓకే ఓకే యా
ఓకే ఐ థింక్
టోటలీ అగ్రీ యా
అజయ్ మేబీ హీ జాయిన్ లెట్ us start
యా ఓకే
so yesterday what we discussed about cloning, zero copy cloning, right?
ఎస్ యా
Hope you got a chance to look into that and hope you got understanding of what is cloning, why we need to go for cloning.
యా
Today, let us move to the cost management and the cost optimization side. So what I was thinking to discuss today is how can we first let us understand how can we try to reduce the cost. So when I say reducing the cost, there are so many ways because whatever we discussed yesterday that is about storage cost optimization. Correct, right? When I say storage cost optimization, the cost always whatever we go and try to reduce not only which will involve in storage cost. Sometimes we need to even focus on the compute cost, data transfer cost, AI services cost, other types of cost also you need to reduce. If I want to go and focus on the compute cost, so compute cost will always depend upon the warehouse consumption. Correct, right? So the compute cost will always based upon the warehouse size plus warehouse type also, which you are selecting as we discussed yesterday,
Yeah.
and the cloud you are selecting and the region you are selecting. These are all will be the factors for compute cost. But if I am only focusing on the query side, what are the things we need to focus? There are certain features which Snowflake is offering, which we can use to optimize your queries and then reduce the cost. The first feature in that is the clustering. When I say clustering, let me show you my screen. So why we need to go for clustering also? Because most of the database or ETL projects which will involve the query execution, these query will consume some resources, and every query whatever you are running, Snowflake will try to generate a query plan, and each and every query will have a query plan, and it will use some set of resources, and it will leverage the warehouse to run the query, and it may do sometimes full table scan according to the filters which you included. And Snowflake also providing a inbuilt feature called caching, which will Snowflake will automatically use it based on the query complexity and query execution. So we have different types of caches also, like a query cache, metadata cache, warehouse cache, and we also have like remote disk cache. These are all basically at caching, which is inbuilt, that will take care of by Snowflake automatically, but which is not under our control. But when we want to control from our side, we have a control over organizing the partitions. What is organizing the partitions we'll discuss. But before going to that, when I talk about performance with respect to any query, especially like SQL queries, we will talk. A query is basically is a very good query based on the time it took. Less query time, I call it as a very like good performance. Long running query, always we people consider that as a bad performance, because it will go and it takes so much amount of time and so much cost also. So we need to focus on how to optimize the queries by improving the performance with less cost. So micro partitions which Snowflake will automatically create will take care for some level, where Snowflake will organize the table into a group of micro partitions. Each micro partition should be considered as a file here. That is the way how Snowflake will do. Second way how we can optimize is scaling up and scaling out. A scaling up is a process where we use whenever a single query is running for a long time, we will try to increase the warehouse size so that the long running query will get additional resources and it will try to run faster. Any group of queries, group of users are experiencing latency. Because of parallel execution also, sometimes people will experience latency, because every user query may be in the queue because there are no additional resources available to run those queries. So to increase the performance of parallel execution, we need to increase the number of clusters. That is called scale out. So this scale up and scale out, scale out can be automatically performed by Snowflake if you have additional clusters available in your warehouse. We do not need to even go and manually go and do that. If my warehouse will have enough clusters, automatic scale out will be done. If no sufficient clusters available, you manually need to increase it. The maximum clusters need to be increased. Even scale up also. The size should be increased using alter warehouse name command. And query result cache, which I mentioned already, this is also a automated inbuilt feature which Snowflake will try to store your results, and we can leverage that also. But one of the unique feature out of all this is cluster keys. What is a cluster key? A cluster key is generally will try to reduce your like number of partitions you are scanning from a table. If you heard about indexes in Oracle or other databases, the index will speed up your query performance by sorting the data on that column. So here cluster keys also will do the same process. In normal databases, you sort your data, the column data in an ascending or descending order, whereas in Snowflake, the cluster keys will group the partitions by sorting them into one cluster. So let us try to see how an example how it will go and try to pick up the cluster keys. So if you observe here, so most of the clusters keys you create, the micro partitions which Snowflake also will create, the size will vary from 50 to 500 MB, but it will be decided by Snowflake automatically. Every table which will be you creating will be divided into a group of micro partitions with compression. The Snowflake knows which algorithm to use, and it will determine the most efficient compression algorithm for the columns in each micro partition, whatever you see here in the right diagram. This is how the storage row 1, row 2, row 3, which we see when we select the data, but the column how it will store the data will be like this. So whatever physically you see, it will be you what you see, and but logically it will store like this in the column storage. I'll show some examples also. Let me show you. The data will be divided into a group of micro partitions, and the actual data is this. Whatever you see, the first 6 rows, if you consider the 2, 4, 3, 2, 3, 2, you can see here 2, 4, 3, 2, 3, 2. And the corresponding names ACC, BAC, you can see here ACC, BAC. It will group like this. Micro partition 1. Now, for example, the first 6 records are in the micro partition 1. The UK, SPDE, all these are nothing but this up to here. And the 11/2 date, you can see here. Like that, it will go and group the records into one micro partition. So every table will be divided into similar kind of micro partitions. As of now, the current data is divided into 4 micro partitions. If you observe this data, the data is not in any order. The micro partitions also having some data which is not order, but if you observe here, the date column, somewhere it is ordered, somewhere it is not. But when you select the data, for example, I will go and run the query, something like this. Let me show you. So I'll go and execute this query. Out of my data, select name, country from this table where type equal to 2 and date equal to 11/2. Let's assume that. So whenever I run this query, the Snowflake query engine has to generate query plan, and it has to add these 2 filters. What is the first filter? Type equal to 2. So type equal to 2 means, if you observe here, the type 2 is present in almost all the micro partitions. 2 is present there. Similar to that, 11/2 also is present in almost the first 3 micro partitions. So according to this criteria, these 2 filters, my data is now available in the for the 11/2, the first 3 micro partitions, but the type 2, all the micro partitions. So this is not required because this is not meeting the second filter. So Snowflake will automatically eliminate this because only 2 is matching here, the 11/2 is not matching here. So out of 4, now we got only 3. Out of these 3, so Snowflake will pick up the records which are matching this 11/2 and it will display. This is when you directly apply this query on the table. Assume that I created a cluster key on the date and type. Alter table name, cluster by date comma type. When you apply this one, right, Snowflake will immediately sort these micro partitions, and this will be anyway eliminated. But the two, wherever you see here, it will sort the micro partitions. Two will come here like this. Can you see that? Whenever 2 is coming here and 11 by 2 is coming, 11 by 2 also it will start. Earlier 11 by 2 is present 3 micro partitions. Now after this, you got into 2 micro partitions. Can you see that? This is also eliminated, right? This both are eliminated now. This is called partition pruning. And this also will be eliminated because the second condition is not matching. Only this condition is matching, but this condition is not matching. So Snowflake will try to eliminate these 3 micro partitions from the list and keep only 1 micro partition, and it will pick up the data from this micro partition only. This will be looks like a smaller group of partitions. It is very fast, but if you go and see, thousands of partitions are there, and out of 1,000 partitions, my cluster key has reduced to 10 micro partitions. You can imagine how much amount of cost you are saving. Almost 9,990 partitions you are pruning or eliminating. Only 10 partitions only contain my whatever data I'm looking for. So we are eliminating 990 micro partitions where you are saving so much amount of cost here. So that is how clustering will generally is going to group the micro partitions and it will sort the data. But it is not like directly we can achieve this. You need to first create a cluster key. If the table is already created, then I need to use alter table name cluster by this approach. If you don't have the table ready and you want to create a table with cluster key, I need to create like this. Create table name, column names and the data types and the cluster by which column you want to create. So there are two different ways to create a cluster key. First by creating along with table creation, or once my table is already present, use alter table name to add a new cluster key. And this cluster key also can be a single or composite cluster key. Composite means you use 2 columns. Here type and date, 2 columns we can use. And coming to like clustering, the main objective of goal of clustering is to minimize the number of partitions, micro partitions you are scanning, and then increase your query performance and increase that speed up your query performance and reduce the cost. So majorly what clustering will do, it will identify the right number of rows by eliminating the unnecessary partitions. So coming to like the cluster keys, generally we cannot go and blindly choose whatever we want. We need to follow some criteria. The cardinality you have to see. The high cardinality, prefer columns with high cardinality always. Avoid low cardinality or Boolean columns. Choose columns used in the range, like dates, numbers, like that. That will save your time and cost also. So that is how you need to go and apply to create a composite cluster key if needed. And when choosing the cluster keys, also Snowflake recommends define cluster keys on only bigger tables, not small tables, because small tables does not see any impact. Minimum we need the data in huge amount of data, billions of data is there, then only go for clustering because that only can show some difference. Don't define cluster key, composite cluster keys on more than 4 columns also. That also is not the feasible. So where to use this cluster keys? Always use columns frequently used in filter conditions or join keys, and frequently used functions or expressions also. Whatever the columns you are using in those particular functions and expressions, use those columns in the cluster keys like date and then metcd. All these are common. So this is sometimes this queries also you need to optimize. Avoid using like this. Don't use function on the column. Always use this function on the value you are verifying like this. Two care. of order date, I'm just verifying with this value. This is going to take so much amount of time because it has to apply the to-char function on an entire column, which is time consuming. If you go and see like this, order date equal to date of this value I can apply. For this value I'm verifying, I'm applying the to date function so that it will run faster than this query. This is one of the example how to go and change and choose the right column and right function on the required column. And also always try to the timestamp columns, if you are using, always go with day, because day is going to give you some unique identification. So we need to follow the same. So let us try to see some examples, then you'll understand better. Just give me a minute. I'm taking some example here where we'll go and create some table here with some decent amount of data. So let me try to create. Let me create the database. Let me create database and schema, and then I'm creating a table also. So Fuzzy and DB, analytics schema, and one table we created, and I'm just inserting some sample data, which is going to be a decent amount of data only I want to insert. Let us try to insert. So it is loading some 1 billion rows into the table. See, now it is going for 3.9 millions. So I'm just trying to go for 100 million rows. So let us wait. Not 100, 10 million, sorry, 10 million rows. I think. So 10 million rows. So we are almost done. See, 10 million rows have been loaded. Now let us try to select the data for this condition. See, this is without cluster key. I'm just running this. Without cluster key, I'm just selecting star from, and I'm just adding some condition on shipping ID. So it took 382 milliseconds. Very fast. Maybe I think that also not sufficient. It looks like. Let me increase the size. Let me insert few more rows. So even 10 million rows also, it is feeding very small amount of data. So let us try to increase some more data. So still it is loading. So I just want to go with 20 million at least. Let us see. So this 20 million rows, we will try to see how much it will take and how many partitions it will divide also we will see. So here we see when we go here in the query profile, it is clearly showing us how many partitions, in total, and how many it is scanned 10 out of 10. That is not correct also, because sometimes the data may not be available in all the partitions. So if it is doing a full table scan, which is not correct, because my data may not be available in all partitions, 10 partitions. So what we have to do, we need to create a cluster key on this. Let us try to create a cluster key on the event type. How to create? I will try to add a cluster key here, and let me try to run this. So I create a cluster key now. So before cluster key created, it was taking 1.2 seconds, something like that, whatever you see. It may reduce or not, but the number of partitions also it may reduce. And let us see. I will use the scanned mismatch here, not event type delay alert. Take the same, and let us see how many partitions is scanned. Is there any reduction? Yeah, it is scanning the same 10 out of 10. But let me try to add one more event type also. Sorry, yes, a shipping ID also to both I will add. So now I added 2 columns to my cluster key, and let us see. I'll only give the mismatch only. And mismatch, the other one. Location update. Let me try to give this also. See, adding a new partition key, a new key to the cluster key is not impacting. It is like increasing the query execution time also. So shipping ID is not the correct column. So what are the other columns available? So event detail is there. Let me try to add that and see. Let us see. But number of partitions, how many partition it has scanned, we have to see that. It may or may not reduce, but sometimes it will reduce. See, can you see that? Total 16 partitions, but it is scanning only 6. Can you see that, everyone?
Yeah.
Which means that it is reducing, right?
Mm.
See, total number of partitions, it is not scanning all. After shuffling the partitions, when we create a cluster key, composite cluster key, the number of partitions that are need to be scanned is reducing.
Mm.
So this is one of the example. The cluster key. What is the conclusion here? Choosing the right cluster key is important, right?
Yes. Yeah.
It can be one key or multiple keys also. Sometimes
Multiple
will
keys.
solve your problem.
Mm.
Assume
Composite keys.
I have 10 billion rows are there. Then you will imagine how useful it is.
Yeah.
Because thousands of partitions will be there sometimes. So if you don't use these cluster keys, the Snowflake will query engine will go and scan all the 1,000. It is 16 or 10 or 1,000, whatever it is. It is not mandatory to scan all the partitions. So we should create a cluster key here, composite cluster key or simple cluster key, whatever it is. That will impact like this. How much amount of data are scanning also important. 60.62 MB and it scanned 86.11 MB almost. Finally, we got the 6 partitions. Out of that only we got the data. The filter has been applied. The where class filter was applied only on the 6 partitions only. Remaining 10 partitions have been eliminated, or we also call it in clustering terminology, the 10 partitions have been pruned. The partition pruning will happen here. Pruning means removing them from the list. So the partitioning you are not going to do, but whatever Snowflake will create like partitions, will leverage them and arrange them in order so that while scanning, Snowflake will only consider the partitions that are need to be scanned, and it will scan only them. Any unnecessary partitions even will be there, it will not even touch them because of cluster key is applied on that. So this is basically the clustering the group of micro partitions. So this is one concept, and apart from this, we also have the two other features also. Let us try to discuss about. We have like search optimization service is another feature, and this is also one of the like service which is chargeable service, and this service also will speed up your query execution. But you need to apply this on the column, especially on the lookup tables. When you are looking up some data, so you need to see like which columns you generally use and how you can go and need to like select only the required columns. So the search optimization service is going to like reduce the lookup tables response time and will increase the performance. So you like normally micro partition pruning, which generally we do, that is basically go with some kind of algorithm Snowflake will use in the background. But the search optimization service feature will create a persistent data structure called a search access path, and it will use that access path every time when you search the data, when you select the data. This path, the search access path, will track which values exist in each micro partitions, and it will act effectively as a secondary index. You know secondary index, right? A table will have not only one index, we can have multiple indexes also in Oracle. Here cluster keys are one of the physical like objects, or we can call them as keys that will try to group the micro partitions, but the search optimization service will have a secondary index to quickly extract the data and display and show us. Mainly when high cardinality is there, 100K plus distinct values are there, where clustering is not even going to help us in that particular scenario, or it can be too expensive also. So the high cardinality columns where even clustering can't help us, the SOS can help us, the search optimization service. And point lookups, whenever you have a lookup data, country lookup, city lookup, state lookup, product category lookup, these kind of data when you are dealing with, always go with search optimization service. So how to go and apply that? We need to enable it, and this feature also available for business critical edition only. It is not available in the standard or enterprise editions. Always please remember that. If at all you want to use or enable the search optimization service, you need to, for a table, you need to say alter table, table name, add search optimization service on which column you want to apply, you will clearly mention on which kind of like lookup search you want to apply. I want to set apply on the equality, or I want to apply on a substring, or I want to apply on a geospatial column. You can clearly mention here. And the user ID and transaction ID, whenever there will be a equality comparison, then I want this particular search after service to directly go and deal with. So cost wise, the Snowflake will not go and give free of for the SOS for free of cost. We need to pay for that. So internally it will use the compute resources. So we need to pay for that. And we can also use the metadata. We use like system dollar search optimization cost also one particular metadata view. And we can also verify is there any search optimization feature applied to your table. You can say describe search optimization service on table name. You can mention like this also. This is going to show us whether my table already got configured this search optimization feature or not. So that we'll see some examples. So the SOS versus the clustering, which we just discussed about, both are having different use cases. The SOS is very best for the lookup data, and automatic clustering is very suitable for sorting the data or range scans, date range scanning, and number scanning, and cardinality, high cardinality columns. If you have, then go with always SOS. Low cardinality columns are there, or medium cardinality, then clustering is the right choice. And columns wise, if you see in SOS, we have multiple independent columns, whereas in clustering, we have hierarchical or correlated columns. And query type, we generally search up automation service will be used for equality check or substring, geospatial data, and virtual, like sorry, variant data, all this. But in case of clustering, a range in between or order by, these are all different features which you can integrate if it is a automatic clustering. So let us try to see some example, then you'll understand better. So my environment is already my type of account. If you see what is this account about, what is this? Can you see that? What I'm using here? The addition.
Business critical.
You have to create an account for similar way. With our 120 days account, you can create. Correct, no? The 120 days URL which I shared you, please use it and create a business critical edition and then try to test this. So let me try to start with. So if your current account is not business critical, you cannot use this feature. So let us try to create some tables here. We need some data, setup data. Let me get that also. Need some base data. Let us use this. Let me create some sample tables so that it will be easy for us. So first I create a warehouse for this. So I create a warehouse to accommodate, and I also will create a database. We go with same public schema. Automatically it will point to public schema only, and the new warehouse which you created is pointing to the new warehouse. And then you create a table. So there is a sample data customer table. I'm just leveraging that, and I'm creating a table from the sample data schema. 5 million rows I'm selecting. So let it create. So it created the 5 million rows data. So let us try to select and see. So we got some data here. So let us try to disable the query cache because I want to see this particular SOS performance also. If you enable query cache, you can't see that. So now I will try to select the data. Select star from customer data is my table, and then customer like SK key is this so and so column. We got some data. Let me get this column. Okay, it took some amount of data. So to verify the before enabling, we need to use it. For all we want to use the search optimization service, you need to enable it. How to enable it? The select system dollar estimate search optimization cost, and for this customer like a data table on equality I want to go and apply, and also substring I want to apply. So two different columns with the two different like features I want to go and use. So I just created that. It is throwing some error. Let me see what is that.
There is a dot after system dot.
Hmm. Need to see. It is now enabling. Just a minute. It is enabled. For these two columns, on is not required. So I just removed that. So two columns. One is the customer SK column and email address column. Two different columns. We applied that. Now we'll try to apply alter table customer data, add search optimization on equality of this one, substring of email address. I'm just adding that. So it has been enabled now. So now let us try to show tables. It will show me whether the search optimization service is enabled or not also. So let me try to see that. Can see it is on. Can you see that? The search optimization is enabled here with on. It means that this table is already can we use the search optimization feature in the background. So let me try to run this query again. I'll add this condition. So now it is coming. So let me try to. So in the query profile, it will clearly show us. In the query profile, if you go here, it will show whether it has used the search optimization service or not in the query profile. So let me try to show you. Clearly saying the query optimizer estimated that the search optimization service would not be beneficial for this table scan. So it is not using because as per the query optimizer, the query, this particular query does not need any such kind of feature because the query is already optimized. So let me try to. So that's all. You have to load some this amount of data, then only you will see the difference because while looking up the data, you need some decent amount of data here. So small amount of data may not show any impact because you need to test with the bigger tables only. So to that is how you can enable search optimization service, and then you can apply and you can see whether the search optimization is used or not here clearly. So this is basically showing it is not used because the query itself as of now is optimized. We do not need to optimize it. Clear? Suresh?
Yeah.
So you need to try this today, okay? You also please try the clustering and micro partitioning also. I'll share the script and try to see if you can reduce the number of partitions also. Similar way. And then try with this search optimization service and try to add more data. Maybe whatever the data I loaded may not be sufficient. Just try with at least minimum 1 billion rows and then try it. You can randomly also load. You can create a random table and this particular example which we checked earlier that was having some data. We loaded almost like 20 million rows are there. You can use that data also and try this and see whether how SOS is getting utilized in the query execution or not. Is okay, Chandra?
Yes, sir.
Please try this. This is very important. As a DBA, we need clustering and micro partitioning and SOS. Both are very important because when you're optimizing your queries, you need to use this particular feature. There is one more feature called query acceleration service also, but that maybe I'll discuss in the next class. Okay then, yeah.
Okay, thank you.
Thank you.
Thank you, Sri.
Yeah, thank you.
Good class.
Okay.